I want to put it out there, way out there, that this is an easy question. If you didn't find it easy, I'm joking, you'll get there. Understand, we are only going to do 2 questions today. I would love to do more, but for me it's more important you understand my way of thinking than just answering a question. I would like you guys to bear with me. I'm going to go very slow, and I'm going to do it with you guys. There we go. Okay, there we go. Fantastic. Okay. Yeah, I'm an amazing artist. Okay? After I've erased 50 times. So, ladies and gents, how do you guys usually approach geometry? Out of experience with my classes. In the diagram below, O is the center of the circle. BD is the diameter of the circle. GEH is a tangent to the circle at E. F and C are 2 points on the circle. FB, FE, FB, BC, CE, and BE are drawn. With E3 or E1 being 32 and E3 being 56. Calculate with reason E2. Okay, wait, let me read the question again. E2. That's how most of you guys approach geometry, am I right? Yeah. And about halfway through you go, just what is this? This is drawn and that is drawn, and guys, please don't. It's going to constantly feel like you are drinking water out of a fire hydrant. Okay? So how do I approach it differently? Little bit by little bit. So it says to me, in the diagram below, O is the center of the circle. Stop. What do I know about the center of the circle? Firstly, I have radii. Do those radii mean anything? No, it doesn't. But I still looked at it. Okay, now let's go further. Theorem 1. Do I have a line from the center of the circle to a chord? I have, but I don't know anything about the chord, so I'm not going to do anything. Theorem 2. Angle at the center, it's a bit iffy, but I can do this, and this gives me 90 degrees, which I would have done in any case when I read that BD is the diameter of the circle. Theorem 3, angles in a semicircle. Okay, now I go on to the next. BD is the diameter of a circle. I've done it on my sketch. GEH is a tangent to the circle. Now here starts the fun. I'm telling you, I'm going to highlight a few things here that you didn't see. Maybe. Well, let's start from the top. There. G5 is B1. There. That one is that one. From the bottom, that one is that one. Somebody again. Should I have been able to see all of those? Yes, if you use your fingers. Okay? But please don't forget, have I looked at theorem 7 and 8, sir? No. Do I have a line from the center to the tangent? No. Do I have two tangents? No. So I'm not going to look at 7 and 8. But I've looked at 9 extensively. Okay, and please use your fingers to make sure you find all the ones that I found. Next up, I go and I look for what? Cyclic quads. Because I must look for them. They are hiding in plain sight. So I like to, first of all, always start by looking for bow ties. Not just because they are very delicious Asian dessert, but because it means those two are also equal. It means as well, what can I make this? Just single line. That one is equal to that one. Okay? Now furthermore, I can go and say, okay, I might have a cyclic quad there. So those two are supplementary. Those ones are supplementary. But because I don't have an exterior angle or bow tie, I don't write it on my sketch. Because it's a bit iffy writing supplementary on my sketch. But I must think about it. Now there is another cyclic quad. Whom of you found the third cyclic quad? Oh, 1 or 2 or 3 or 4 or 5. There's a cyclic quad. FEDB. Now I'm not going to highlight that one for this time. But now let's go further. Okay, well all the other ones just mean that they've got a lot of straight lines. So now they tell me, extra bit of information, that is 32 and that is 56. Now I can go and fill in all the rest. If that is 56, that is 34. If that is 34, that is 34. If that is 32, that is 32. If that whole one is 32, 34, 56, 122, because those, I can go and say, well, those two are supplementary, 58 degrees. So this one is also 58 degrees. Which means these two together are also 58 degrees. Okay, sorry, let's quickly stop. Let's look at the questions. Because I haven't looked at a single question. Oh, determine the value of E2. Oh, but I've got it. It's 34. Determine the value of angle EBC. 66. Determine the value of angle F. But sir, you didn't even look at the questions. No, I didn't. And yet I answered more. I even have angle C. I've got angle D. I've got angle E4 and 5 as well. I have so much more than I need by just going systematically through the theorems. So now the question is, how do I write it down? Well, I would start by saying, okay, well, how did I get that one to be 34? Now I go, what do I know about E2? Guys, look at the way I approach it. I look at the answer. They're asking me for E2. Now I ask myself, what in my theorems told me something about E2? But E2 plus E3 must be 90 degrees. Angles in semicircle. So therefore E2 is 34 degrees. There's my first one. The second one is now I'm looking for B2 and B3. Well, I've got a few choices. I'm going to go with B3 because I need something with B3. B3 is the same as E2, which is 34 degrees. Look at the way I write it. I don't just say B3 is 34. No, B3 is E2, which is 34. Because then the examiner knows what I made it equal to. Not just a value, an angle. And this is angles in angles in same segment. What am I writing? Absolute nonsense, sir. Angles in same segment. Now, why is B2 32? Well, B2 is E1. Tan chord. And lastly, therefore, angle EBC is 66 degrees. My challenge to you guys are, if you are really smart and you're getting really bored in this class today, find more than one way to do this. Find 2, 3, find as many ways possible, because you'll never see this question again. But you'll see a similar type of one. The more ways you can find, the better you are. And the better you'll be for the future. Now, angle C, I'm saying that angle F is equal to angle E1, E2, as well as E3. So I'm going to say E1 plus 2 plus 3. You are allowed to write it like that. And this is 122 degrees. Tan chord. Okay. Everyone all right with that?